Hello mathematicians, in this video I'm going to show you how to use your CAS calculator to find a heap of different data, box plots, mean, median, quartiles, all that stuff. We'll have to talk about outliers so we can analyze some data given here. Make a quick note of the data and we'll go to our CAS. Making sure we have a new document or a new problem at least, we go add lists and spreadsheets, so number 4. And I'm just going to type in the data here. So that was 1, 5. So I'm typing it in like this. Bum, 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 5, 5, 6, 7. Come on. 6, 7, 8, 9, 10. Make sure you press enter at this point. You'd be surprised how often it goes wrong because people don't. Now we need to label our columns, call them anything, but just don't call them single letters for reasons that you'll see if you do call them single letters. So I'm going to call it instructor A and instructor B. First thing we can do is generate a graph to show this data. So I'm going to go Command, Insert, Data and Statistics. And we click down here and we're going to add instructor A. And what you can see there, just looking very casually, is that there are a couple of very spread out bits of data, but everything else is quite close together. What we can also do, if we want to do a side-by-side comparison, we can go Menu, Plot Properties, and we can add an X variable. So that's another one that we had before. Don't add the Y variable or it'll try and do a scatter graph or something. And we can now see those two sets of data. Now let's try and think about this as we're going along. What can we immediately say about those sets of data? Well, what's quite striking is the spread. And we can talk about which one is more spread out. Instructor A, the absolute range, as in the smallest subtracted from the largest, is much, much bigger. But for instructor B, generally speaking, the data is more spread out. So if we go back to our data, we'll start doing some comparisons here. So we'll have instructor A and instructor B. The range for A is 16 minus 1, which is 15. Make sure you do give 15 and not just like 1 to 16. And for B, it's 10 minus 2, which is 8. But as you can see, that doesn't really capture what's going on. That's why we use box plots and interquartile range. So we're going to go Menu, Plot Type, we convert it to a box plot, and what we can now see is for the bottom one, if you do this, go Menu, Analyze, Trace, and just press on the left and right and up and down arrow keys, and we can see various different things. Gone down there, we can see all these numbers. Now, I'm going to put this into the whiteboard and we're going to discuss what these mean and how we can find outliers. So we'll start with the quartiles, which we could have worked out using the data up here. We know there are 10 items, so the median is going to be here. So we can say that the median for A is 6.5 and the median for B is 5.5. So based on the median, just as it looks, we would say that B is better because obviously we want smaller numbers of errors. Okay, that's obviously not the whole story. If we then find the median of each of those halves, that gives us the quartile. So we could call that Q2, which is like the median. The median of that first set gives us the first quartile. So we can write here quartile 1 for instructor A was 6 and for B was 4. And then quartile 3 is here. We have 7 and 8. Now the quartiles tell us how the data is split into quarters. So it's easiest to see on the bottom one here. We have the lowest 25%, then we have the next 25%, then we have the next 25%, and the final 25%. And this allows us to find the range of the middle 50%. So that is the interquartile range, which you really need to have remembered hard as the range of the middle 50%. And we could have read these numbers off the graph, or whether we found them from the graph or from the data. The interquartile range is 7 minus 6, which is 1 for instructor A, and for B it's 8 minus 4, which is 4. So when we're commenting on the spread, we could actually say that instructor B is more spread out because the middle 50% is more spread out. So we have slightly conflicting bits of information that we have to consider as a whole. Now you can see that for instructor A, the box plot looks rather different to B. That's because A has outliers and B doesn't. So at this point we should talk about how we find outliers. So let's drag this over here. There is a bit of a procedure here, and we just have to kind of go with it. We find 1.5 times the interquartile range, which is whatever it is, and we are going to do, we find that value, then we do Q1 minus that number, 1.5 times the interquartile range, and we do the upper quartile plus 1.5 times the interquartile range, and these give us our fences for outliers. So let's do that for both instructors. So we would have the lower fence. I'll work out what 1.5 times the interquartile range is first, because that just makes it easier rather than doing everything in your head. Interquartile range for A was 1, so 1 times 1.5 is 1.5. And for B, it was 4, the interquartile range was 4, so 4 times 1.5 is 6. Then for A, I'm going to do Q1 plus 1.5, sorry, minus 1.5, 6 minus 1.5, which is 4.5. And if I do Q3 plus 1.5, that gives me 8.5. Now, how does that affect the graph? The lower fence is going to be here, so 4.5. That's 5, isn't it? So it'll be about here. And the upper fence was 8.5, which is about here. That means anything outside of those lines is considered an outlier. So we can see that the 16 up here was an outlier and that the one down here was an outlier. Now, I don't extend the graph here all the way until the fence. We only extend it as far as the last item of data, which was inside the fence, which in this case was 7. And actually, we don't extend it at all because 7 was the upper quartile. Going down on the left-hand side, the next lowest data item was 5. So that's the first one that's inside the fence of 4.5. So that's 5 there. So that's why we only extend that line down as far as 5. Now let's repeat the process for instructor B. If we do Q1 minus 1.5, let's write that again, of course. So that was 4 minus 6 is negative 2, which is down here. So clearly, it's impossible to have any outliers there. And then the upper quartile, so that's going to be 8 plus 4, which is 12. So the upper fence would be here, which is well past all of our data. So in this case, these values here do represent the maximum and the minimum. And we normally, when we're drawing these, we stick little dashes on the side. So let's go back to our original question, which was who is the better instructor? Well, it's never as straightforward as that, but we can see that on average, instructor B has fewer errors, which is good, but we can see that instructor A is far more consistent, except for a few outliers. One of the big questions we'd ask here is how many errors do you need to pass the test? Because if, let's say, you pass the test as long as you get less than 10 errors, then you would choose instructor B anyway, because based on this data, there is a lower chance of failing with instructor B than there is with instructor A. Now there's one more bit of analysis that we can undertake with this. Notice that the median is not really affected by changes in extreme data. So if I change 16, suppose this person did really badly and actually got 160 errors, that would send this data off far on to the right, but it wouldn't affect the median, it wouldn't affect the quartiles or the interquartile range. That's not the case when we consider the mean and the standard deviation. So in our head, all of the things you can see on the screen kind of go together: median, quartiles, interquartile range. But then we can consider two more things: the mean and the standard deviation. So let's go back to our CAS. We will go to number 1, and we're going to go menu, statistics, calculations, one variable statistics. Now, why is it one variable when we've got two people? Really, it's one variable for two different cases. So the variable we're investigating is the number of errors. Now, almost always the number of lists is 1. You could actually do 2 lists here, but because I've almost never ever seen it, I'm just going to do one list here. I'm going to press delete here. There. I'm going to press the right button, and as long as you haven't, as long as you did use a new menu, a new document or a new problem, then there shouldn't be too much stuff here. Frequency list is 1. I'll show you in a moment how that can change, and we're going to put the result in column C. So we press enter there, and let's look at the information we can glean. We have the mean here, which is 6.8, and the standard deviation of this one, which is 3.51. Let's compare that for instructor B. So we're going to go menu, statistics, calculations, one variable stats, and the X1 list. We'll press delete, press the right button, get to instructor B, press tab to move between the fields, and we're going to put the result in E. You can see that's the first free one, and when we go down now, we can see the mean for B is 5.9, and the standard deviation is 2.47. Oh, I should have rounded the 1 to 3.52. Okay, now I'll just very quickly show you, if we had been super ninjas on this, we could have just said 2 lists. X1 list is instructor A, X2 list is instructor B, and it puts the things side by side, but it's very rare to actually use that. So what comparison can we make here? We would say, based on this, instructor A is definitely worse because they've got a higher mean, and we'd say the standard deviation, the amount spread, is much higher. But that includes all of the items of data, including outliers. So that's artificially spread out. And that's pros and cons, right? Including all the data is good because you include all the information, but it's bad because it's affected by extreme values. Now, finally, I want to show you how we can use the data when it's presented in a slightly different form. So now, here comes instructor C, who has presented a lot more information in a frequency table. And I'll show you how to enter this into your CAD. Now, the first thing we need to note is that we can only provide estimates from this thing because we don't actually know. For example, there are 2 people who got between 0 and 2, but we don't know whether that was whether they got 0s or 2s or what. So we don't know the absolute minimum here. It could be 0, 1, or 2. The absolute maximum could be 15, 16, or 17. So to do this estimate, we are going to find the midpoint of each of these classes. And the way we do that is, for example, we do 0 plus 2 divided by 2, which gives us 1. Midpoint there is 1. 3 plus 5 divided by 2 equals 4. And you can kind of see that all of these work out nicely. You do have to work it out properly for at least one of them. Sometimes it'll be something 0.5, it won't be completely obvious. Now, let's put these numbers into the CAS, where the number of errors is represented by the midpoint, so 1, 4, 7, 10, etc. And then we'll have the frequency 276. So let's do that now. we are going to insert a new problem for this. So document, insert problem, add lists and spreadsheets, putting in, so this was the errors, and we'll call this one the frequency. We'll put the numbers in 1, 4, 7, 10, 13, and 16, 2, 7, 6, 3, 1, 1. Okay, and we will start with a data and statistics. And see, if we go and we put the errors here, we can kind of see that that looks a bit flat, doesn't it? Because we've got like just 5 items, because we haven't told the CAS about the frequencies. The way we do that, we go menu, plot properties, add Y summary list. Now that is not an obvious name for it, so we just have to go along with it. We'll put frequency, and that now looks a lot more like what we were expecting. Again, we can change the plot type to a box plot, and we could perform the analysis in exactly the same way. So analyze, trace, find all the various bits of data. So that shows you how to do it using the graph. If I wanted to do it using the one variable stats, we go menu, statistics, calculations. It's still one variable. There's still only one thing that we're measuring. We've just got 2 lists, but the only thing we're measuring is the number of errors. Still one list. Where it changes is here. So we delete, press right. We've got errors there. Hopefully you might have guessed. Frequency list is frequency. Tab the way down to the bottom. And a good little check here is that n equals 20. And if we scroll down, we can see we've got Q1, the median. Didn't show you these on the last one. It says the minimum and the maximum, but it's just kind of guessing. Well, it doesn't know that we've used categorical data. And yeah, you can see the standard deviation there and the mean there. Now, the final comparison we might make between these 3 instructors is discussion of skew. So the first one, if we just consider the middle bit here, we can see it's pretty much symmetrical. So if we were to draw a graph, we'd have most people in the middle and then everything fanning out to the side. In fact, I might be able to show you that on the CAD. If we change this back to a dot plot, that's not perfect, but you can see everything's kind of bunched up here. One might argue that it's a bit negatively skewed. In fact, the skew shows more on the top one here than it does on the bottom one, but it's because I used a small amount. This one, we can see there's definitely more data to the right of the median than the left. So it's going to look more like this. I'll draw this a bit better. So it drops off steeply there, goes along a bit further that way. So we would describe this one as roughly symmetrical. Maybe a bit negative, but a bit positive, sorry. This one we would definitely say it's positively skewed because the tail has been skewed, dragged up in the positive direction. Have a look at the bottom one. What do you think? Hopefully you are thinking to yourself, this is more like a negative skew because there's more stuff on the left-hand side of the median. So we would describe that as negative skew. Hopefully, folks, that is everything you need to analyze data using your calculator.